Hello everyone. Today's topic for presentation is Geographic Information Systems. It is presented by Jordan Frey and Aditya Patil. What is Geographic Information System? It is a system designed to capture, store, manipulate, analyze, manage, and present all types of geographical data. It lets us visualize, question, analyze, and interpret data to understand relationships, patterns, and trends in the data. Simply put, a combines layers of information about a place to give a better understanding of that place. GIS is a system of computer hardware, software, data, and personnel to manage, analyze, and present information about a location. GIS links maps to databases and creates a visualization of data and allows interactivity between the map and the data in databases. Basically, it is a database management system for spatial data, also known as geographical data.
So why do we need GIS? A GIS provides decision makers within an organization the ability to more easily analyze spatial data. Going beyond simple analysis, they allow us to delve deeper into the data. We can ask the who, what, when, where, why, and how with regard to that data. There are many applications of GIS. Like we said earlier, GIS allows us to visualize spatial data and perform analyses on that data. It can be used for flight tracking, environmental science, and demographic analysis, as well as other applications. GIS and big data are interrelated. Like we said in previous classes, big data is the high volume, velocity, and variety of data. And it is related to GIS primarily through environmental observation systems. These systems are constantly collecting geographic and environmental data, both in real and near real time. This data comes in many forms, including imagery, and this causes issues with storage and interoperability.
Look at our planet. It's not just continents and rivers. It's 8 billion people living, working, and interacting with their environments. The world's gone global. Global economies, societies, markets, all interrelated and affecting each other. By understanding these correlations, we can solve global challenges and solve tough problems at a scale like never before. Geospatial big data is a living, digital inventory of the surface of our planet derived from over 5 billion square kilometers of current and historical imagery and information. This inventory enables you to find, count, and measure features of the Earth's surface like never before. Let's look at an example use case. Suppose you're a retailer that wants to open up a new store. First, you'd look at the globe highlighting your successful stores and unsuccessful stores. Looking at these areas, you could dig into the customer base. What are the conditions of their neighborhoods? Are their yards well kept? How many cars are in the driveway? What's the square footage of their house? You might then look at the towns as a whole. How many houses are there? Have the towns been experiencing growth? How many cars are there total? Have the economic centers been moving or developing? You can see how as the picture grows, from a neighborhood, to a town, to a state or even a country, you start to get more information. Intuitively, you could guess that the locations with the nice lawns or nice cars are experiencing growth and would be more attractive. But let's let the data speak for itself. Geospatial big data has already enabled a number of industries and government applications to find trends and correlations that help them answer the tough questions they're facing.
Now let's have a look at how GIS data is captured. It is captured with the help of global positioning system devices, satellites, aircrafts, or drones. Global positioning system devices uses global navigation satellite systems, also known as GNSS. It is based on radio signals broadcasted by satellites. GPS devices detect this signal and use them to triangulate the position. The less obstructed a GPS device is, the more satellites that can be detected, and it increases the accuracy of detected position.
So satellites contain multispectral scanners and thematic mappers. These scanners detect different bands of light in the visual and infrared spectrums. Images are formed from these bands that emphasize certain geographic features. They can also contain active radar systems. These are based on a transmitter and receiver technique. They beam microwaves, which are outside of the visual spectrum, onto the Earth's surface, and then reflected beams are then processed into images. This collects reliable data in most weather conditions, including at night.
Aircrafts. Aircrafts possess every system that a satellite has, plus it has LiDAR system. LiDAR is a laser-based radar system. It uses strength and timing of beam to calculate various parameters such as ground height, canopy height, water surface, and even water clarity.
Drones are also used and are equipped the same as aircraft. They are increasingly used as an alternative to manned aircraft. In one particular case study, a South Carolina county deployed drones to survey the impact of Hurricane Matthew. They flew drones over coastal areas before and after the hurricane to create 3D maps quantifying damages, flooding, and erosion. This saved time and money that would have previously been used for similar monitoring by aircraft.
Let's have a look at how GIS data is stored. It is stored in a geodatabase, which is a type of relational database. There are three main types of geodatabase. First is enterprise geodatabase. It is a collection of various types of GIS datasets held in a table in a relational database. Second one is a file geodatabase, which is similar to enterprise geodatabase, but rather than storing data in a table in a relational database, the data is stored in a file system folder. And the third one is personal database. It is original data format for ArcGIS geodatabase stored and managed in applications such as MS Access.
There are two main file types in which GIS data is stored. The first is the raster file type. This is based on a grid system where each cell has a unique ID or primary key. This represents continuous features such as elevation or temperature. The other is a vector file type. Vector files represent discrete variables or count data, such as population size or parcel boundaries. There are several problems in GIS, however. The main problem is spatial accuracy, since points, lines, and polygons are only models of real-life entities. They cannot be created with 100% precision. The other problem is missing data. And because there's a large amount of data to be analyzed, the speed at which it can be analyzed can sometimes be problematic.